In Module 9, we'll be working with rational expressions and equations. We learned in the previous module, and even before that, the adjective rational, the root in that word rational is ratio, and ratio means fraction. So these are going to be expressions that are written in the form of a fraction, and also equations that deal with fractions, but more specifically with fractions that contain polynomials, where there's polynomials in the numerator and polynomials in the denominator. So expressions get simplified, right? From the time that you first started learning algebra, expressions can also be factored, but expressions typically get simplified, and when you simplify, you're just doing operations. You're adding, subtracting, multiplying, and dividing. So that's what we're going to do here. And since the root in the word rational is ratio, the steps here are going to be very similar, nearly identical to the steps for adding, subtracting, multiplying, and dividing fractions. So we started off the year with a unit on just this. So these notes, again, are going to be almost identical step by step. So like for adding and subtracting rational expressions. Well, now this part is new because since we are working with polynomials, you wouldn't have seen this first step before, but we want to make sure that the denominators are in factored form. When you're adding or subtracting, there is no need to factor the numerators. But once we have the denominators in factored form, we want a least common denominator, just like we saw at the beginning of the year. Once you identify your least common denominator, you're going to multiply each numerator by the same factor as the denominator. Whatever you multiplied by on the bottom, you multiply on the top. Then we're going to simplify the numerators since there's variables involved. That could involve removing parentheses by distributing or by foiling. That could involve combining like terms. Then at the end, you would factor the numerator. Once you're done simplifying the numerator, you want to factor the numerator. You've already factored the denominator. The denominator has stayed in factored form. So the reason why now you want to factor the numerator is because if the numerator and denominator were to have a common factor, that common factor could be reduced. Once you're done reducing, then you would simplify whatever's left over. Because also we're dealing with variables that have unknown numbers, at the end, by the time we're done, we also want to state restrictions on the variable. When you see this word restriction in this unit, it's basically the same thing as discontinuities. When we were graphing last module, we used the word discontinuities. Now we use the restrictions. It's the same thing. Okay. When you add and subtract rational functions, all these restrictions is pretty simple to find. You can just find them in the LCD. If you've identified the LCD, you can find the restrictions in the LCD, in the least common denominator. When you multiply and divide rational expressions, well, let's start off with multiplying. Now we're going to factor both the numerator and the denominator. We're going to put both of them in factored form so that we can reduce if possible. If you have common factors, they can be canceled vertically. They can also be canceled diagonally. Any factor that the numerator has in common with anywhere in the denominator can be canceled out. Then at the end you would multiply, which that could again involve foiling or distributing. And just simplify. And then finally at the end again state the restrictions on the variable. Any factor that spent any time in the denominator at all needs to be restricted. Dividing rational expressions. Okay, we're going to still factor as we did before with multiplying both numerator and denominator, but since we don't divide fractions, we learned that instead we're going to multiply by the reciprocal, which is going to be copy, change, flip. And once we do this, now we're back to following the steps that we did before with multiplying. Follow all the steps that we did at the top of the page, because now you would have changed the operation to multiplication. Then finally, at the end of this module, we're going to be solving rational equations, which it isn't as easy as step 1, step 2, step 3, step 4, but overall what we're going to be trying to accomplish is to simplify both sides of the equation. We're going to try to do any operations. If they're asking us to add, we'll add. If they want us to subtract, we'll subtract. So simplify both sides so that we end up with a proportion. A proportion is just an equal sign with one fraction on one side and one fraction on the other side. So that once I have this proportion, normally a proportion you solve by cross multiplying, and that could be done here, but see, now we're going to be multiplying polynomials. If you cross multiply, what could happen is that the degree can get really big really fast. And since you're trying to solve an equation, the bigger that the degree gets, you've seen this before when we solve polynomial equations, the bigger the degree, the longer it takes, the more of a hassle it is. So in order to try to keep our degree as low as possible, what we're going to do is we're going to factor the denominators. We're going to have this proportion, and we're going to factor both denominators. Then, once we have these denominators, we're going to identify a least common denominator, and we're going to multiply both sides by that least common denominator. And what that will do is that will remove the fractions for us. That will keep our degrees as small as possible, and then we'll solve. When you have a, I should add this step here. When you have a rational equation, by the time you're done solving, there is one more step at the end, and that's that you need to check for extraneous solutions. You've seen the concept of an extraneous solution already this year when we did absolute value equations. You'll see them again later on with radical equations and with logarithmic equations. So we need to check for extraneous solutions. Now, this can be done easily. There's a shortcut for this. On rational equations, all we have to do is compare our solutions to our restrictions. Solutions are what variables are allowed to be. Restrictions are what variables are not allowed to be. If a restriction matches up with a solution, then you can't count that solution as a solution. You have to throw it away because it's extraneous.